Welcome to lecture series on data structures. In today's lecture series, we will discuss about some of the sorting algorithm. Uh, the sorting algorithm that we are going to discuss today is bubble sort. So, as you all know, why do we actually perform sorting? Is that if you want to arrange the given set of elements in a particular order, be it ascending order, descending order, you need to perform sorting. So we have various sorting algorithms. So of that, bubble sort is the most basic sorting algorithm. So idea behind this bubble sort is the bubbles in the water. So why do bubbles in water move upwards and how do they move upwards? So when you answer for these two questions, you will have a good idea of what bubble sort is all about. When a bubble move upward, the water from above will move downward to fill the space left by the bubble. So when you move the largest element to the end, the element from the end will move forward, move backward to space to fill the space left behind by the largest element. So this is the logic behind the working of bubble sort. So here is an example of bubble sort. We have set of elements here 9, 6, 2, 12, 11, 9, 3 and 7. So here bubbles are compares the number in pair from left to right and exchanges the values whenever it is necessary. Here the first number is compared with the second and if they are larger then they are exchanged. Now the next pair of number is compared again 9. Now compare 9 and 6. 9 is larger so it is exchanged. So it will be like 6, 9. Again 9 and 2 is compared. Again 9 is greatest, so again exchange. So 6 to 9 is the next order. The third comparison, 9, you will compare 9 and 12. Here 9 is not greater than 12, so it is not exchange. Now you compare 12 with 11, it is greatest, exchange 11 and 12. In the next step, you will compare 12 with 9. Again 12 is greater than 9, so exchange. Again you compare 12 with 3, yes it is greater, exchange. Now at last compare 12 with 7. Yes, 12 is greater than 7. Again you have to exchange. So this is how bubble sort works. Here is an example. So in the first pass, after performing the first pass, the values will be arranged like this: 6, 2, 9, 11, 9, 3, 7 and 12. So in the second pass, again you have to start comparing from the first two values. 6 is greater than 2, exchange. Again 6 is less than 9, no exchange. 9 is less than 11, no exchange. 11 is greater than 9, exchange. So 9, 11. 11 is greater than the exchange. 11 is greater than 7, exchange. 11 is less than 12, do not exchange. So the values will be like 2, 6, 9, 3, 7, 11 and 12. So similarly, this is a result of third pass. In the step here only 9 is greater than 3. So you will exchange again 9 is greater than 7. You will exchange. After that no more exchanges will happen. This is the result of fourth pass where mm, 9 is greater than 7. 3 you will exchange. Again 9 is greater than 7. You will exchange. Here, so two exchanges took place. And in the last and the fifth pass, if you look at the fifth pass, second step, 6 is greater than 3, it is exchange. After that, no more exchanges. So this is a final sorted order of given set of elements with the help of bubble sort. So here are few questions to have a better understanding on what is bubble sort. So which number is definitely in its correct position at the end of the first pass? So at the end, you see, in case of bubble sort, now look at the previous slide, that each step, the largest values move to the last. This is how bubble sort works. So after the first pass, the maximum value will be the largest, and after the second pass, the next maximum value will occupy the second position from the last. And in the third pass, the third largest value will occupy the third position from the last. So this is how bubble sort works. So how does the number of comparison require change as the pass number increase? So each pass requires only few comparison than the last. So so you go through all these quizzes. Here is another example for a bubble sort. So here you have to note down that at least one element will be in the correct position at the end of each pass, whose position will left unchanged. Here is analysis of bubble sort algorithm. Its worst case time complexity is n square and best case is order of n. It is a bidirectional bubble sort algorithm. We have two, one is bidirectional and original bubble sort. So original bubble sort will work only in one directional, whereas bidirectional bubble sort will work in both the directions. So if you take the classification of sorting algorithm, we have two types. One is internal sorting, other one is external sorting. Under internal sorting, we have two algorithms like bubble sort and insertion sort. Here are some of the assignments for you to practice. So the operation that segregates the item into groups according to specific criteria is sorting, and sorting can be done in main memory is called as internal sorting. Here, the internal set of sorting algorithm of these four is insertion sort. Uh, in bubble sort, the largest element is always moved at the highest index in the array. And in insertion sort, it is a good choice for sorting list of few thousand of items or less. Hope you understood what is bubble sort. In the next lecture video, we will discuss with some other interesting topic. Thanks for watching.